Hello students, welcome back. So in this module we are going to discuss the problems which are based on continuous function and domain of a function. What does the question say? X cube minus 8 upon x square plus x minus 20 is continuous on which domain? Students, we know that f of x is continuous on its domain except where its denominator becomes 0. Therefore, x square plus x minus 20 should be equal to 0. So by factorization, we need plus 1 and minus 20. So it is plus 5x and minus 4x minus 20, which is equal to 0. So keeping x common, it would be x into x plus 5 minus 4 into x plus 5, which is equal to 0. So the factors which we get is x plus 5 and x minus 4, which is equal to 0, and hence the value of x are minus 5 and plus 4. So hence the range is nothing but minus 5 to plus 4, and we have option B as the correct answer. Moving ahead, you have a function which is given in a domain of 0 to 6 and you have interval at 0.4. So you need to check it is continuous at which points and which not. So as given in the question, a domain is in between 0 to 6. So f of x is continuous on its domain except where denominator becomes 0. Then x minus 3 is equal to 0. So the value of x which we get is plus 3. And since this value is in the interval, f of x is continuous on 0, 4, where 0 is an closed interval, 4 is an open. Except at which point x is equal to 3. Now, in another case, in 4 to 6, denominator, that is x minus 2 is equal to 0. Hence, we get the value of x as plus 2. But this 2 is not in the range. As a result, the f of x is continuous on that whole range, that is of 4 to 6. But the value of f of 4 is 4 square minus 1 upon 4 minus 2, and which would give me 15 by 2. So, since we have interval at 4, we have to check the left hand limit and the right hand limit. So, for 4 minus, the function is x is tending towards 4, x square minus 3x plus 2 by x minus 3, and which is equal to 16 minus 12 plus 2 upon 4 minus 3, whose value is given by 6. And for the right hand limit, the value of the function would be x square minus 1 upon x minus 2, whose value is 16 minus 1 by 4 minus 2, which is nothing but 15 by 2. My dear students, if you have observed, they both values are not same, and hence the function is discontinuous at x equal to 4. So hence we can say that function is continuous on that domain 0 to 6 except at x equal to 3 and x equal to 4, and hence option D is the correct answer. You need to find the value of a and b. If we have solved the sums in theory, yes. So in this case, at x is equal to pi by 4, the left hand limit which we get is limit x is tending to pi by 4 minus function is x plus a root 2 sine x. So as x is tending towards pi by 4, and by substitution x minus pi by 4 is h, and hence limit h will tend towards 0. Equation would be pi by 4 plus h plus a root 2 into sine of pi by 4 plus h. As h is tending towards 0, the value which we get is pi by 4 plus a root 2 into 1 by root 2 for sine pi by 4. And y as root 2 get cancelled, what we get is pi by 4 plus a. Now for the right hand limit, the function is 2x cot x plus b. So when h is tending towards 0, it would be 2 into pi by 4 plus h into cot of pi by 4 plus h plus b. As a result, after solution, as h is tending towards 0, the value would be only pi by 2 plus b. For continuity, the left hand limit is to be equal to right hand limit, and hence a plus pi by 4 should be equal to b plus pi by 2. And hence the equation which we get is a minus b should be equal to pi by 4. Now, let's go on another interval of at x is equal to pi by 2. The left hand limit For pi by 2 minus, equation is 2x cot x plus b. So when h is tending towards 0, 2 into pi by 2 plus h into cot of pi by 2 plus h plus b. And as h is tending towards 0, we know that cot of pi by 2 is 0. As a result, the value which we get is only plus b. For the right hand limit, it would be x is tending towards pi by 2 plus a into cos of 2 of pi by 2 plus h minus b into sine of pi by 2 plus h. As a result, we get minus a minus b, and for continuity, they both should be equal. So minus a minus b is equal to plus b, and hence a plus 2b is 2. And once you solve both the equations, the value which you get is a as pi by 6 and b as minus pi by 12, and hence option is the correct answer. Now, if f of x is continuous at x equal to 2 and we have two different conditions for 2 minus and 2 plus, you need to find the value of t. Students, a function is already continuous. So what to do? We know that 2 minus f of x should be equal to 2 plus f of x. As a result, limit x is tending towards 2 minus 4x minus 3 should be equal to limit x is tending towards 2 plus into kx plus 7. As a result, 8 minus 3 would be equal to 2k plus 7, and hence phi is equal to 2k plus 7, which gives you 2k as minus 2, and hence the value of k is minus 1, giving you option A as the correct answer. Thank you.